Welcome to my video. In this video we're going to look at algorithms, how information is inputted into them, how the information is processed, and then how the information is outputted from them. On the screen I have the basic model of input, process, output. Before we go any further, I just want to point out that a computer program is an implementation of an algorithm. They are not the same thing. The most simplistic form of input, process, output I can show you is the inputting of a number, processing that number in some way, such as adding 10 to it, and then outputting that number to the screen. Here's the example. So I've inputted 6. It goes in, it's passed to process. Process takes 6 and multiplies it by 10, and obviously the answer is quite simple, it comes out as 60. That answer is then passed across to output and then output to the screen. And that's basically the process that every computer system that we have to date uses. Okay? Here's another scenario that you'll probably be more familiar with. Here I've got a gamepad. Okay? When you're playing a game, you are moving the joysticks and pressing these buttons here and pressing the D-pad and the power button and the start and the menu button all of the time, probably thousands of times a second. That's a lot of inputs that are being passed across the process with a lot of outputs. So let's simplify that down just to 1 or 2 inputs. So if I was to move one of the joysticks, potentially that could pass in an X and a Y coordinate. That's passed across. That could be processed. So it processes the X and Y coordinates. The console would do that for the game, depending on the game that you're playing. Okay? That could then be outputted in one of a few forms. It could be outputted in the fact that the character moves across the screen, maybe left or right or up or down. It could be outputted in the form of sound, of his footsteps running across the map or across the screen. It might be even the fact that he bashes up against the wall, and again, it could be a sound or maybe even a vibration. So although this is an input device that has allowed us to input, it may have the little vibrations here. Okay? Again, therefore that could be used as an output as well. Moving forward. So, building on that, the first model I showed you was input, process, output, often known as IPO. This one is input, process, storage, output. So the storage goes there. Okay? So how does that work then? So an input is basically the stage where you take external data or information and pass it into the system, okay, or into the algorithm. Okay, it doesn't always have to be external information. Process is basically how you take that information and how you use it. Okay, is it used in some form of calculation or some form of decision? Okay, storage, and this is an interesting one. Storage can either be to store the result of a process or store a piece of information temporarily because maybe we're going to do some other calculations or some other processing to that piece of information. So basically, it's stored it when it's not immediately needed, okay, or stored it for later on when we may need it, okay. And then output is basically outputting the result of a process, okay, that has taken place within the program or algorithm. Okay, I hope that's quite easy to understand. Let's put some scenarios into place. Now this one's going to be really simple, then I'm going to let you have a go at one. So here I've got a scenario in which I want to work out the area of some carpet. Okay, now in maths I'm sure you're aware that to work out the area it's length times width. So I've got 7.5 times 4.5. Okay, so if we were making this into a program, think about it. The inputs would be the length, the width, and the data type of those would be real stroke float. Now real and float's the same thing. Okay, all that means is it's like 7.5 or 6.5 or 6.3. It's got a decimal point in it basically. Okay, now the process would be working out that equation, so the length times the width to get the answer. Okay, and the output would be outputting the answer to that to the screen. Okay, so in fact, very simplistic. I want to move forward. Here's a scenario that you're going to stop, pause and have a go at. So, scenario 2. This is for a vehicle rental company. They want a program basically that does the following. Write a program which asks for the vehicle type and the amount of whole miles the vehicle has covered. The program should check if the vehicle is a car. If the vehicle is a car, then mileage is charged at 30 pence per mile. Otherwise, it is 60 pence per mile. It should then output the cost of using this vehicle for the journey. Okay, so pause now and see if you can identify what are the inputs, what process is going to take place, and then basically what outputs are going to come out from the system. Pause because I'm about to press the thing if you want to. So I've got the inputs are the vehicle type. Now I've said that that's a data type of string because obviously they might enter car, they might enter boat, they might enter the model number, so they might enter BMW 320, mileage. And here, look, notice the word whole. Okay, I said it was a whole number, so therefore the mileage is going to be an integer. The process here would be the mileage times 30, or the mileage times 60, depending on whether or not that condition is met or not. Okay, and then there we would output the cost, which would be the result of this one or this one, depending on which one it is, which would also be a real, because obviously, because we're timesing by 0.30, there's a good chance that the result is going to be a decimal number as well. Okay, so that's there, look, potentially could be a decimal number because of that or that. Okay, moving forward. So let's break it down a little bit further. So just to clarify, in your exam you might be asked to identify where the inputs are, where the processes are, or where the outputs are. Now that might be from a scenario like this one, or they may give you some code and ask you to identify them in the code. So let's try it from the code this time. So let's break it up. So here, input, so I'm going to input 12. Okay, so straight away I know that's an input. Here I'm going to input 33, and here I'm going to work out that 12 plus 33 is in fact 45, and then I'm going to output the answer. Now based on how I've just said that, you should be able to work out the answers. So if we look at that, look, these two are in fact inputs because it's taking inputs from the user. This one has in fact done some calculation, so therefore it's a process, and then this one has output the answer to the user. Super simplistic. Let's look at this scenario then. So I've got a flowchart, okay? I've got a flowchart, okay? Here, it sets something. It sets answer to 6. That's not an input, is it? Okay? Here, I take a user input in the form of a guess, okay? Here, I set this value to 1, okay? Here, I check whether or not something is true or not. So if guess is not equal to answer, okay, it's going to come down here. If guess is equal to answer, it's going to go across here, based on the true or false commands. Okay? So let's have a look at those, and then let's look at this here. Can you spot the first input? Okay? Well, I'm hoping you're pointing at this one. And let's have a look. Let's say we have in fact got two inputs, because we take an input here, and we take an input here, because it's allowed inputting of information. Okay? Now we've got some processes. Here, look, these two are where the information is being set. Okay? And this one again is where it's being set. The variables are being assigned. Okay? Values. Okay? They have not been inputted. They were already inside of the system. Okay? Outputs then. So here, look, there's only one output, and it outputs correct. Perfect. Let's take the same scenario and compare it in its pseudocode form. So here's some pseudocode. So I've got start, answer equals 6, and so on. So again, feel free to pause here and see if you can spot the similarities. I'm just going to pop them straight on the screen. Now if we were to compare them together, you would see they work exactly the same. Okay? So just to clarify, look, this one here is allowing the user to input, this one's outputting information, and these ones here are processes. This is the process of assigning, and then this one here is the process of basically redeclaring, isn't it? Because it's taking this existing variable, which was 1, and then it's basically adding 1 to it, so it's getting a new value, it's incrementing. Okay, that leads me to the overview of input, process, output. So what do you need to know for your exam? You need to be able to identify what inputs are, what processes are, and what outputs are. And let's have a look at some little tips for you. Inputs, they're often the point in the program that allows the user to interact. They're not always, but often. It is important to choose a logical name or appropriate data type. So for example, if it's a guess, a great name for it is going to be guess. Okay? And then the data type depends on what data you're expecting it to have. So for example, on this example, the guess, I'm expecting a number. So therefore, I would set that to the data type of integer, because it's a whole number I'm expecting. Okay? Inputs are normally the information that is needed to allow the task or program to complete. That's very true. If we go back to this example here, that is in fact correct, because without that user input there, well, this program can't continue. Okay? Process. Processes, often the calculations that I need to perform or solve the problem. Okay? Data types may change in this process. So for example, if you're trying to compare an integer and a string together, that's not possible because the data types need to be the same. So you may need to convert one to the other data type so you can compare the two against each other. Okay? Variables may be reassigned. Okay? You just saw that. So if we come back here, look, we saw a variable that has been reassigned a new value. Okay. Outputs. Often outputs are outputted to the user in the form of feedback. Okay. There's a number of things like that. So it could be correct, you got the answer right, or it could be in a less subtle form, such as vibration through the gamepad, sound played through speakers, or a physical movement that you can see on the screen of the character moving. Okay. Again, with outputs, it's important to use appropriate names and data types for the same reason I mentioned with inputs. Sorry. So that leads me to the end of this video. I hope you've enjoyed it. If you've got any questions, please feel free to contact me. Thank you.